welcome back, guys. Today we're going to be talking about direct variation. Direct variation, we have some new vocabulary here. First of all, direct variation is the equation in y equals kx form, where k is a constant number, it's a constant rate of change. So it's very similar to the y equals mx form that you have seen in the past, where m represents your slope. Constant of variation is the number k, the constant term. It is the same as the slope of the line. This is also referred to as the constant of proportionality. Some other terms that you may hear interchangeably here is direct variation or varies directly. That's the same thing as your constant variation and your constant of proportionality. So, let's talk about what proportionality is. First of all, what is the root word of proportionality? Well, if you look right here, we have proportion. So, really, what is a proportion? Well, we set up proportions by setting one ratio equal to another ratio. So it looks like a fraction equal to another fraction. Sometimes they are set and we can decide if they are proportions or not. And most of the time we deal with proportions, it has a missing piece. So we have to solve that proportion. And how do we solve proportions? Well, we solve proportions with the butterfly method. So you would say that whatever A times D is equal to whatever C times B is. So we would say A times D is equal to C times B. People may refer to this as the butterfly method, because look here at my cute little butterfly. Another math term that you may use to identify this is cross products, because that's what you're doing, is you're multiplying the numbers across. To solve a missing piece of the proportion, we do the cross product of the two pieces that we know, and then we divide it by the piece that's left over, because that undoes that multiplication to find our missing link. For instance, if I knew what A and D was, I could multiply them together. If I knew what C was, I would divide both sides by C to get B by itself. So you will hear me refer to cross multiply and divide. That is the same thing as cross products or your butterfly method. So let's look at some examples. If I wanted to solve this, for me to cross multiply and divide, I'm going to do the 8 times 13, because those are the two numbers that I have across from each other that I know. So I'm going to say 8 times 13 is 104. And then I'm going to say 104 divided by 2 is equal to 52. So x equals 52. What I just did there was I did my cross multiplication. I did 8 times 13 to get 104, and then I divided by my leftover number there. So let's try this one. I'm going to say 10 times 4, because they're across from each other. 10 times 4 is 40. 10 times 4 is equal to 40. I'm left with this 8, so I'm going to say 40 divided by 8 is 5. So x is equal to 5. And then one more example down here. I have 10 over 12 is equal to 2 over x. 12 times 2 is 24. And then when I divide 24 by 10, the main reason I wanted to add this example in here is I get a decimal number, 2.4, 2 and 4 tenths. It is perfectly fine to have a decimal as your answer when you're solving a proportion. That is not very uncommon. It's something that happens quite a bit. It's weird to us because we don't typically see fractions that look like this. If I were to sub this 2 and 4 tenths back in for x, we don't normally see a decimal inside of a fraction. But in the case of proportions, it is okay because we're just solving for that missing piece. So, let's talk about what proportionality looks like. If I have a direct variation equation in y equals mx form, they are always set up just like this, y equals mx. Keep in mind that m means slope. You find that by doing your change in y over your change in x, just like you've done in the past, y2 minus y1 over x2 minus x sub 1, or rise up your y-axis, run across your x-axis. We always do slope in y over x. The other thing that I want to keep in mind is that the direct variation equation always goes through the origin. It's in y equals mx form. You notice that there is no plus b. So it would be like adding a 0 or going through the origin. So if we were to graph any direct variation equation, it should be a linear equation, a straight line that always travels through the origin. And that's how we know if it is proportional or not. So, some of the questions you may get look like this. Suppose y varies directly as x when y is 15 and x is 5. They may want you to write a direct variation equation that relates x and y. So the first thing I'm going to do is find that constant variation, which is just like finding my slope. So for slope, I always do my change in y over my change in x. So if y is 15, I would put 15 over x is 5. And then when I simplify 15 over 5, I get 3. So my slope is 3. So if I were to write that as a direct variation equation, I'm just going to write that in y equals mx form. I would say y equals, substitute in my 3x. Now I have a direct variation equation where I can plug values in for y and solve for x, or sub values in for x and solve for y. So, if my problem continued, same problem as before, we have our y equals 3x, and it says use the direct variation equation to find x when y is negative 45, we can just plug that in. If y is negative 45, I'm going to substitute a negative 45 in here for y. So I'll say negative 45 is equal to 3x. Well, if I'm looking for x, now all I have is a simple one-step equation. 3x means 3 times x. To undo multiplication, I divide. If I do it to one side, I've got to do it to the other. Negative 45 divided by 3 becomes a negative 15. So x is equal to negative 15. Now, that's all fine and good, but we have an easier way to do that. We just got through talking about how direct variation is a proportional relationship. So, since direct variation is proportional, we can just set up a proportion. If I knew what y was and x, I'm going to set up my proportion. Make sure that y's stay on top together. Make sure that x's stay on bottom together. Now you could set it up x over y as long as you keep your x's together and your y's together. You also want to keep your constant together and then your solution together. So it's going to look like this. Suppose y varies directly as x. When y is 15, I'm going to put a 15 up here for y. When x is 5, keeping those two together, set that equal to, use that to find x. So I'm looking for x, so it's going to stay my variable, when y is negative 45. So on the y level, I have to plug in my negative 45. Now I can cross multiply and divide, so I'm going to say negative 45 times 5, and when I do that, I get negative 225. And then to divide, I just cross multiplied these two numbers together. So I'm left with my 15 over here, so I say negative 225 divided by 15 gives me a negative 15. And that was the same answer that we got earlier by setting up our direct variation equation. So unless it asks you for that specific direct variation equation, you can always solve it by just setting up a proportion. So let's take a look at some of the examples that we did today in class. The number of goals scored by a soccer team varies directly as the number of shots on goal. So varies directly tells me that it is a proportional relationship. The Lakeside Bears scored 2 goals after 24 shots on goal. So I'm going to say this is how many goals they scored out of how many shots on goals. And I like to set up my ratio here using letters to symbolize which I'm doing so I can keep them organized. So they scored 2 goals, so goals were 2, after they took 24 shots on the goal. How many shots on the goal, so shots is what I'm looking for, so that's where I'm going to leave my X. Should the team take to score 2 more goals. Well, I already had 2, so to make 2 more goals, that would make that 4. So now I just have a basic proportion here to set up. 24 times 4. 24 times 4 is equal to 96. And then I'm going to divide that by 2. 96 divided by 2 gives me 48. So the team would have to shoot 48 more shots on the goal in attempts to try to score 4 total. Let's look at another example. This one's a little more cut and dry. It says if the circumference of a circle varies directly, there's my keywords again, so we know this is proportionate. If the circumference of a circle varies directly as the radius, if the circle has a circumference of 157 feet with a radius of 25 feet, what is the radius of a circle? What is the radius of a circle with a circumference of 39.25? So my circumference over radius. My circumference of the given was 157, and the radius was 25. So in my other situation, it wants to know what the radius is, so I'm going to label that as R, keeping it down on the bottom with my other radius. If the circumference is 39 and 25 So when I cross multiply and divide, 39.25 times 25, I get 981.25. And then when I divide that by 157, my new radius is 6.25. Make sure that you're checking for reasonableness. If the circumference went down, you know your radius should go down as well. So that's one thing to kind of keep in mind, is the reasonableness of your answer. Alright, well, I hope you enjoyed today's lesson.